Alrighty, so here we go, day one. All right, we're gonna jump into, this unit is mostly gonna focus on like lines and circles and functions. It's kind of like a hodgepodge of things, which is really a good description of all of pre-calculus. It's like a hodgepodge of different topics that are meant to kind of just get you ready for calculus, right? Some things we need to cover that you just don't quite cover sometimes very thoroughly or thoroughly enough in like algebra 2 and geometry and algebra 1 and stuff. So, anywho, all right, let's dive right in here. Okay, so today we're gonna be looking at distance formula, midpoint formula, okay, and goodness, I think, and then lines it looks like, okay, and then lines. Okay, so quite a bit to cover there, okay. All right, so let's jump right in here first to the distance formula. Okay, so before I give you the actual formula though here, I'll kind of like refresh your memory a little bit about what the distance formula really is. Okay, the distance formula, I mean the distance between 2 points in the coordinate plane. So for example, if we have a point A that has coordinates x1, comma y1, and we'll say point B that has coordinates x2, comma y2. Okay, and we want to find the distance here from A to B. Okay. Now, if that segment was horizontal, right, that'd be easy. You just count. You know, how many boxes do you go from left to right for that distance, right? If AB was vertical, also easy. You just count how many boxes do you go up, you know, from bottom to top kind of thing. But for a diagonal, right, it's a little bit trickier. But what we do is we put another point in here, call it C. Okay. C is going to be directly below point B and directly to the right of point A. Okay. Alternatively, you could put point C up here, make it above A and to the left of B, but just for our purposes, that's where we're going to put it. Okay. Since C is directly below point B, what do we know about one of its coordinates? Since C is directly below point B, what do we know about one of C's coordinates here?
The x-coordinate is the same.
The x-coordinate will be the same, exactly right. Since it's directly below, it's not moving left or right of B at all, so it will also have x-coordinate of x sub 2. Okay. Likewise, what do we know about C's y-coordinate? What must it be? Same as the y of A, so y sub 1. Okay. C is not higher or lower than A, and so it's going to have the same y-coordinate. C is not left or right of B, so it's going to have the same x-coordinate there. Okay. Now, by doing that, we've created vertical and horizontal distances, right? What is the measure of segment AC going to be? Or how can we find the length between A to C? What could we do there mathematically? The distance from A to C. What's that going to be? Or how can we represent it, maybe? Yeah?
x2 minus x1.
x2 minus x1, right, yeah. Take the x-coordinate here, right? This is the x, x2 right there. And subtract the x1, and that'll give us that distance. So x sub 2 minus x sub 1. You got it. Okay? That's that distance from A to C. How about the measure of segment BC? What would that be? Or what would be an expression that we could write for that? Again, this distance right here. What would that be? Yeah. y2 minus y1, exactly right. Okay? Now remember, our purpose here, right, we're trying to find the distance from A to B. We're trying to find the distance from A to B. But now we have the length from A to C and the length from C to B. If you have this side and this side, well, actually, what kind of shape is this right here? It's a triangle, and specifically what kind of triangle? A right triangle. And we have two of the legs, okay? And so we want to find this third missing side called the hypotenuse, right? And what can we use to what can we use to kind of relate all three sides of a right triangle? Pythagorean theorem, right? It's a squared, leg squared, plus b squared, another leg squared, equals c squared, the hypotenuse squared. Okay? For our purposes, right, for this triangle here, AC is going to be one of the legs, BC will be the other leg, right? And then the measure of AB will be the hypotenuse, and that is our goal, right? But of course, we have an expression for this situation. We know what the measure of AC is. It's going to be x2 minus x1. And then BC will be y2 minus y1. And then the measure of AB, well, that's what we're trying to find, okay? And we'll just go ahead and call that the distance, right? D. Okay. But of course, we're not interested in what the distance squared is. We just want the distance. And so to simplify this, to get the distance by itself, what should we do to both sides of the equation here? Square root it, right? So D equals the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Now technically, because I'm in an equation setting here, when you square root both sides, technically I should put what in front of the square root? Plus or minus, right? But in this case, I'm only leaving the positive version. Why? It's a distance, right? It doesn't make sense in the context to have a negative distance. Distance is positive, okay? So we're not going to worry about the plus or minus there. We'll leave it just like this. Okay, so there's our distance formula. You'll need to have that memorized. Okay, you'll need to have that memorized. Okay, so let's do an example here. Find the distance. From A to B here. Okay, and again, if I'm going too fast, if I write something you're not sure what I wrote, please, please say something. All right. My handwriting is not that great, and I do move pretty quickly. But part of the reason why I write the notes while you guys are writing the notes is so that way I don't get too far ahead of you. Okay. Let's go ahead, take 30 seconds there, right? That one should be easy for you guys. You go ahead. Go from there. Do the distance formula. Simplify it as much as you can. So no calculators here. Don't give me a decimal answer. Simplify it as much as you can. Okay. Okay. Still catching up, or? Yes. Okay. All right. So again, just because we got to keep moving here for today, we have less time. But there is what your setup should be: square root of 20. But we can simplify that further, right? Simplify square roots. And there's a couple different ways you can think about simplifying square roots, right? Sometimes, you know, if you want to, you can like just try and like kind of guess and check, or not guess and check, but just like, you know your division, your what evenly divides 20, like your factors of 20. And one of those is 4, right? So the square root of 20 is the same thing as saying the square root of 4 times 5. And I choose 4 specifically because 4 is a perfect square, right? So this is then equal to the square root of 4 times the square root of 5. And the square root of 4 we know is 2. Okay? 5 can't break down any further, and so that's going to be our final answer there. 2 times the square root of 5. Okay? That's our simplified answer. Right. Is this wrong? No, not wrong. But if it says simplify, you need to be able to simplify. Okay? And if I give you like a multiple choice question on a quiz or a test, you're going to need to be able to match your answer to what is on the multiple choice. Okay? So make sure you're able to simplify stuff too. Questions on that one? Okay, how about this one then? Let's say that our distance from A to B is 10. A has coordinates -2, 3. B has coordinates x, comma, -3. Find x. So the first problem we did, straightforward, right? Plug and chug. Next one, a little bit of twist. Right. A little bit of a twist here. But we can still use distance formula, right? Distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared here. Okay, whoops. What are we going to put in for D here? 10, right? We're told the distance in this problem, it's 10. Okay, what's one of my x coordinates? -2, sure. What's the other x coordinate? X, okay. Plus, and then we'll do the other y coordinate. So we'll do 3 minus the -3 squared. Okay, this is kind of interesting here. Maybe let's try and make life easier for ourselves. How can I get rid of this square root? What can I do to both sides to get rid of that square root? Square both sides, right? So we end up with squaring both sides. That becomes 100 over here. And since the square root, we're square rooting the entire side here. We're square rooting the entire side. So when we square it, that's just going to cancel out, and we're left with -2 minus x squared plus, and I'll go ahead and add this, so it's going to be 6 squared there. Okay. Well, 6 squared, we know that's 36. And I can subtract 36 from both sides here. Okay, so 100 minus 36 is 64, and that's going to equal to -2 minus x squared. And there's a couple different ways you guys could go about doing this. Okay, but this is one way. At this point, how should we continue to solve? What should we do from here? We want to solve for x, right? So we need to get that x by itself. What's with the x that we need to get rid of there? What's that? Square root both sides. Yeah, we want to get rid of that square. So that's one option. If anyone else thought about like, hey, why don't we just FOIL this out here, do -2 minus x times a -2 minus x, and then solve from there. You can do it that way too. But since we already have, let's just go ahead and square root both sides here. Okay. So now, again, we're in that equation setting. So, and I'm square rooting both sides. I should really put a plus or minus 8 here, and then a -2 minus x. Okay, plus or minus 8 equals -2 minus x. So in other words, I have positive 8 equals -2 minus x, and -8 equals -2 minus x. Okay, we'll add the 2 over, get 10 equals -x, so x is -10. Or add the 2 over, we'll get -6 equals -x, so x is +6. Two possible answers there. Two possible answers. Okay. Now don't worry, I know we haven't really covered quadratics, we haven't reviewed them, but this is stuff that you guys have seen in the past, right? Something that you should, potentially be able to do. Maybe the cobwebs need to be cleared out a little bit, right? We'll cover more quadratics more carefully here, but there's an example of something we should be able to do. Okay? Questions on any of that? Okay. Moving on then. I'll do this. So we're also going to take a look at midpoint formula. Let's see. This one I don't have a long-winded explanation for. You're welcome. Okay, but you also must have this memorized. Okay, I will not be giving it to you. There are some formulas I will give you. Okay. So given that A, you have a point A, x1 comma y1, and B, x2 comma y2, the coordinates of the midpoint of segment AB is that. Okay. Is that. Okay, or put more simply, it is the average of the x coordinates and it's the average of the y coordinates, right? How do you find the average of two things? You add them up and divide by 2. So you're going to find the average of the two x coordinates, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, and that gives you the coordinate for the midpoint, right? So go ahead, take like 2 seconds here, find the midpoint of AB, segment AB, given A is at 3, 0, and B is at 5, 4. Our old friends from the previous problem there. Okay, so go ahead, take 2 seconds and do that. While some of you are finishing up, I do really try and give you guys time to work on your homework in class too. You know, when it's possible. It's not always possible. All right, it's just sometimes we have too much to cover in a certain day. So, you know, I apologize for when that happens because I know that means it's a long day for you guys. But for the most part, I do try and make sure that you get time to work on stuff in class. Sometimes we'll have more than enough time to get homework done in class and you know, actually finish it and stuff too. So, you know, it really just depends. But I do try and get you homework. Get you time to do it in class so that way you can ask me questions too, because I know a lot of your parents maybe can't help you with it or something like that and whatnot. So anyway, all right, volunteer for this. Someone want to give an answer? All right, go ahead, Megan. 4, 2 is right. Okay, yeah. So 5 plus 3 over 2. 4 plus 0 over 2. So that's 8 over 2 is 4, and 4 over 2 is 2. And so that's the coordinate for the midpoint there. All right. Questions on any of that? All right, moving on. So let's talk about lines. All right, already been in the coordinate plane. Talk about lines. There's two, different ways to write the equation of a line, right? Bless you. So one way, the one you guys are probably like your bread and butter kind of way of doing something, is the slope-intercept form, right? That's everyone loves that. Y equals mx plus b. Maybe we don't really know how to use it sometimes, right? But we can at least recite that part. Okay. We call it slope-intercept form because when a equation of a line is written in this format, because there's many ways to write the equation for a line, right? But when we have it written in this format, the numbers reveal both the slope and the y-intercept, okay, of that line. All right? So it's helpful to have it written that way because we can then graph the equation for the line very easily from that information. All right. Let me throw an alternative at you here, and especially for those of you that like really plan on moving on to calculus. All right. I would highly recommend that you begin to adopt this method of writing the equation of a line, which is called point-slope form. Perhaps you've seen it before. Okay. And point-slope form is y minus y1 equals m times x minus x1. Okay, where these, the y1 and x1, are coordinates of any point on the line. Okay, and then you still have to find the slope too. Okay, so the beauty of point-slope form is that it requires less specific information than slope-intercept form, right? Slope-intercept form, in order to write that equation of that line, you need a slope and the y-intercept, a very specific point. For number 2, to write the equation of that same line, you only need a point that's on the line, and of course the slope, okay, as well. So a little bit easier, all right. By the way that where this comes from, this formatting, it comes from the slope formula. If you remember the slope formula, right, that is equal to m equals y2 minus y1 over x2 minus x1, right? That's the slope formula. Well, if you multiply both sides by the denominator, the quantity x2 minus x1, okay, the denominator will cancel out with this, leaving you with y2 minus y1, there, y minus y1, equals m times x minus x1, and there it is right there. Okay, so it's just like a manipulation of the slope formula. Okay. You really, for our purposes, for our class, you should be familiar with both forms. Okay. I'm showing them both to you, so you should be comfortable with both of them. All right. Just a heads up. All right. Of course, we also talk about the slopes and things too, right? Okay. Parallel lines. How do the slopes of parallel lines relate? They are what? The same. Same slope. And we should technically also specify different y-intercept. Because if two lines have both the same slope and the same y-intercept, what's true about those two lines? They're the same line. And they can't really be parallel when you're the same line, right? So we should specify that too. But typically, we just say just the same slope, which I get that. All right. Of course, we can't talk about parallel without also talking about perpendicular. Okay, what's true about perpendicular lines? Their slopes are what? Inverse. What do you mean by that? Okay, so how do you mean by reverse? Reverse, mathematically, can mean a lot of different things, I would say, right? So let me just give you an example. If I gave you the slope of 1/2, what would be a perpendicular slope to that? 2. Close. What would it have to be? Yeah. -2, right, okay. And so then, Sydney, can you explain then what do we need for a perpendicular slope? What did you do? We took 1/2, and you said it had to be -2 over 1. That's what you were going to say, right? Yeah. So what did we do to get from here to here? What did you have to do?
Flip it, and then you flip the side.
Yeah, exactly right, okay. Opposite reciprocal is what I'm going to say, okay. So opposite reciprocal slopes. Okay, opposite reciprocal slopes. By the way, folks, if I ever call on you and you're really not feeling like answering, you can say I don't know, or you say I'm not sure. That's fine, okay? I mean, sometimes I will push you a little bit, just to kind of because I think you can still do it or not. But I promise I will really do my best to not make you embarrassed in front of the class as much as I can. All right. Anyway. Vertical lines and horizontal lines, I want to throw those in too. Okay, a horizontal line is y equals blank, where that blank is a number. Okay, vertical line is x equals blank, where x is a number. Okay. All right, that's typically how you write it. What's true about the slope of a horizontal line? The slope will be what? 0. What's true about the slope of a vertical line? The slope will be undefined, or a number over 0, right? Horizontal line, 0 over a number. That's the slope, right? Vertical line would be a number over 0, divided by 0 there. All right. Parallel, perpendicular, or neither. Okay, that's the question you're going to answer for these 3 sets of lines. All right, here's the first set. X plus 3y equals 7, 4x plus y equals 6. Second set, 6x plus 4y equals 8, 3x plus 2y equals 1. And third set, 12x plus 10y equals 32. Negative 6x minus 5y equals negative 16. Okay? So, do what you need to do here to figure out whether these lines are parallel, perpendicular, or neither. Some suggestions, right? Right now, these are in what we would call standard form. These don't really give you the slopes that easily of those lines, right? Maybe you have a way to get the slope really quickly from standard form. There is a way to do that, okay? Or maybe you want to rewrite this in slope-intercept form and then use the slopes and stuff like that for it. Okay? But anyway, 1, 2, 3, identify if they're parallel, perpendicular, or neither. All right, so go ahead and do that here. I'll kind of come around. I do have tissues, yes, over there on the filing cabinet if you want to need that. I know it takes the season. So all I need to answer for 1, 2, 3 is, are they neither? Are they not parallel or perpendicular? Are they parallel or perpendicular? You want to check with someone next to you, that's fine too. And I'll walk around too, so feel free to grab me as I'm walking around to help you out and stuff. The Google Classroom app on its own is attached to something like the assignment thing. So if you want to go down now. A few folks still working here, so I'll give you guys a chance to keep finishing up. Like one more minute, and then we'll go over this. Okay, 1 more minute. All right, how about a volunteer for number 1? Volunteer for number 1. Go ahead, Melody.
Neither.
Neither, okay, neither. All right, did you put in like slope-intercept form or something like that, or, okay, and they had different slopes, okay, but not opposite reciprocal. Okay, cool. How about another volunteer for number 2? Volunteer for number 2. All right, go ahead.
Parallel.
Parallel, okay. And so you got their slopes to be the same, huh? All right. And then how about that last one then, number 3? Go ahead.
Same lines.
Same line. So then what would we say for our options here? Neither. Exactly right. Yes. So hopefully you didn't just assume it was going to be perpendicular because there was 3 options and 3 problems, right? Number 3, yeah, it did turn out to be neither there. They have the same slope, but they're also the same y-intercept, so it's the same line. All right. So that's it. All right. So if I could, just for to let you guys know, right? So the Google Classroom, it will have your assignment listed there. So just check there for your assignment. Second, if you would please, if there's a book in your desk that's not yours, please now place that on your desk for the next student that's coming for you. Okay. I appreciate it. All right, and they will appreciate it too. All right. You can see who sits in your seat next block. Okay, but again, your homework should be attached to the Google Classroom once I'm done here.